Hey everyone, and welcome to another Explainer. I am absolutely thrilled to have all of our 8th grade learners joining us today. Now, if you've been studying physical science, you've definitely heard of Sir Isaac Newton and his 3 famous laws of motion. But today, well, we're going to look at these rules in a completely new light. We usually learn them one by one, kind of like isolated chapters in a textbook. But the big idea for today is that Newton's laws are actually not isolated rules at all. They're an integrated team. Think of them as a squad of physical principles that work together simultaneously to make our entire modern world possible.
To get our minds primed, ask yourself this massive question. How does a multi-ton rocket actually defy gravity and leave the ground? I mean, sure, it's easy to just say rocket fuel, right? But the real answer lies in the incredible power of integrated physics. It takes a complete system of laws working in absolute, perfect harmony to push something that colossal up into the stars. And by the end of this explainer, you're going to know exactly how that happens.
So here is our roadmap for today. First, the power of systems. Second, physics on the field. Third, safety on the road. Fourth, launching into space. And finally, number 5, the godly learner philosophy.
All right, let's dive right in.
Section 1. The power of systems.
Out in the real world, most engineering marvels, things like bridges, cars, airplanes, they rely on all 3 of Newton's laws operating as a single cohesive system. When engineers sit down to design, they have to consider inertia, force, mass, acceleration, and action-reaction all at the exact same time. This idea of careful, really comprehensive planning connects beautifully to what we read in Proverbs 21 verse 5, "The plans of the diligent lead surely to abundance." Think about what a diligent planner actually does. They don't just look at one single piece of the puzzle, right? They look at the whole picture. So just like a diligent planner, a smart engineer combines all of these physical principles wisely to achieve success and abundance in their designs.
And that brings us to our core definition. An integrated system is a setup where Newton's 3 laws work together to ensure safety, efficiency, and peak performance. Understanding these laws as a complete system makes problem-solving infinitely more effective. Like, if you try to build a machine only thinking about force, but you totally forget about inertia and reaction, your machine is going to fail. You need the whole shebang, the whole system.
Moving on to Section 2. Physics on the field.
Okay, let's bring this down to earth. I want you to imagine yourself standing right in the middle of a freshly cut soccer pitch. The crowd is cheering, the ball is right at your feet, and you are about to take a penalty kick. Believe it or not, you're about to trigger a really complex, integrated physics system in the span of just a single second. Let's walk through it. Yes, the first law, inertia, is happening right away. It keeps the ball sitting perfectly still on the grass until you act upon it. And then, bam, the second law kicks in. The force of your foot interacting with the mass of the ball causes a rapid acceleration toward the goal. And finally, the third law happens at the exact millisecond of impact. There is an equal and opposite reaction force from the ball pushing right back against your foot. That's actually why you can physically feel the kick. See, the laws are working as a total team.
All right, Section 3. Safety on the road.
So physics isn't just for scoring goals, it is literally a matter of life and death out on the highway. Engineers use this exact same integrated system of laws to ensure our survival during high-speed travel, heavy braking, and, heaven forbid, car crashes. Now, what's really interesting about this slide is the stark contrast we're looking at here. Over on the left, designing a vehicle while only thinking about one law, that is incredibly dangerous and incomplete. If you only design an engine to apply force, but don't plan for how to stop the car's massive weight, you have an absolute disaster on your hands. On the right, we see the diligent approach, designing with all 3 laws. Engineers have to calculate the exact stopping force required and account for the precise reaction forces between the tires and the road.
To really see this in action, let's break down the terrifying reality of a car crash test. When a car suddenly hits a barrier, step 1 is inertia. The car itself stops, but the passengers' bodies, they want to keep moving forward at whatever the original speed was. So step 2 requires an engineered intervention. Seatbelts step in to provide an unbalanced force, decelerating the passenger's mass safely. And step 3 involves that third law. The brakes clamp down, the tires push against the road, and the road pushes back against the tires with equal force to actually halt the vehicle. It's amazing. Each law consecutively steps in to save lives.
Which brings us to Section 4, launching into space.
Okay, it is time to finally answer the massive question we asked at the very beginning by scaling things up to the extreme. It is a breathtaking reality that the exact same sequence of physics that moves a tiny soccer ball is what pushes a giant rocket through the atmosphere. Step 1, that massive rocket's inertia keeps it totally still on the launch pad. Step 2, the powerful thruster engines ignite, applying a gargantuan amount of force to accelerate that massive weight.
Step 3, as those exhaust gases blast downward toward the Earth and the atmosphere push back upward with an equal and opposite force, creating the liftoff that rockets the ship into space. How cool is that?
So the crucial point here is being able to identify these systems in action. Let's do a rapid-fire review. Question 1. Can you give an example of all 3 laws in sports? 2. How about in vehicles? 3. How do the laws work together in rocket flight? 4. Why is it absolutely crucial for engineers to use all 3? And 5. Which law do you personally think is most important in sports, and why? I highly encourage you to hit pause right now and answer these for yourself.
And finally, Section 5, the Godly Learner Philosophy.
As we wrap up our physical science lesson, let's transition from the physical laws of nature to the moral laws of life. Just as physical laws have to be integrated for a system to work, our minds and our hearts must be integrated for our lives to work properly. This is the core thesis of the HeroesMart Academy Godly Learner series. They intertwine biblical morality with education because, honestly, education without morality will hurt. Just think about it for a second. What is the point of being incredibly smart and supposedly educated if you just continue to make bad choices that end up hurting yourself and the people around you? Just like ignoring a law of physics leads to an engineering disaster, having intellectual knowledge without biblical morality leads to pain. We absolutely must pair a sharp mind with a solid moral compass.
And this brilliantly illustrates our final takeaway, which is grounded in Romans 8, verses 6 through 7. It promises peace of mind to everyone who keeps their mind spiritual. This is the real experience of people engaged deeply with this content. True abundance, whether you're out there designing a rocket ship or just navigating your daily life as an 8th grader, comes from aligning both the physical mind and the spiritual mind. So I'm going to leave you with this provocative thought to chew on. Are you building your life like a diligent engineer integrating both sharp knowledge and a spiritual mind to achieve true peace? Keep learning, keep questioning, and I will see you in the next explainer.